Welcome to the pilot episode of EMA Ops, a channel that would have been called Big Data because of this, but it was already taken, so here we are. EMA is me, Ops is not operations, it's opinions, because I have a lot of things to say apparently, and I can show you how things work in everything tech and data and whatsoever. So today as a pilot, we're going to start from one of my latest article of my blog, which you can see right here, tsql.tech, which I may expand because now tsql is a small part of my day by day, so we will see. But let me just show you how this will work by analyzing this article of mine. So today's video is about this article, which is about a SQL script to automatically infer the data types of data that someone just dumped in your DB with no effort. Why? Because usually I get CSV files from random people with no information about the schema. What's the data types? What's the schema? Are they null or not? What's the maximum size? What's the minimum size? Etc. And then, of course, you have to do everything by yourself, which is something I don't want to do because, like you, I'm very, very lazy. So what did I do? I created this script and the article, which I will now explain to you because the article is very easy because I didn't put that much detail into it. But the script itself is has a little bit of a nuance that I want to explain to you. So you can definitely go in and expand on the script itself. So quickly through the article, let me go to the use cases. So use case is you receive a CSV file with no metadata attached. So CSV file, you barely know what's the separator of the various fields, which is annoying, I know. What I usually do is dump it immediately into SQL Server using a flat file importer, which could be in SSMS or PowerShell, whatever, I don't care. I just want everything there because then with SQL, I can do my test faster as opposed to scrolling through the file manually in my local machine. Because if the file is big enough, it will be a real pain. So this is why this article was born. After the 100 file I received, I say, okay, let's do it automatically. I can't be bothered anymore because SSMS and other tool give you the possibility of automatically inferring the data types, but they don't work perfectly all the time. So you have to do it yourself, the fine tuning. With this article and this with the code, it's a little bit easier to see which data type you should be setting at the end of the day. So let's get over it. So what I'm doing here is basically using the power of trial and error and dynamic SQL, because at the core idea of this script, it's simply using try convert. You know, try convert is a function that tries to convert a value you pass to it to the data type that you are asking it to convert. So for example, you pass a value, which of course could be a string, and say, oh, try to convert this to integer. And then if it converts correctly, you get the integer value. Otherwise, you get null. So my idea is very simple. I simply say, okay, take this column, try to convert it in different data types, and if the number of nulls in the output column is 0, if there is no a null as an input, of course. So if the number of nulls is the same, is 0, so it means that the number of converted value is the same as the number of original values, then that means that you were able to convert successfully all the values. So that data type could very well be the right data type to apply to this. We will see the full code in a bit, but the level of output that you get is very, very simple. And you can see it like this. So for each column in input, for example, description, industry, level, size, etc. In my example, you get the current type, which of course in my case is nvarchar because I dumped everything right away, no question asked. the current length, which in my case it's irrelevant because it's just dumped straight away. And then the important part is from here on, you get the proposed type, so the type which this value is compatible with. Then you get the required length, which is basically the maximum length of the content existing in this temporary table that you just dump the data in, and the minimum length of this data. As you can see in the description column, you get a proposed type instead of n varchar of varchar, and you can see that the maximum length of data inside of it is actually 128 and not over 1000, and the minimum length is 18. But even better, in order for you to check the code, you can also see a data sample, because I take top 5 data samples from inside the data, so you have a better understanding and a better idea of what's actually inside of it. So when you're going to define the schema of the final table, it actually makes sense and you know what's the content. The same goes for all the others, but let me show you a decent example, which is here, the level column, because description and industry, they're compatible with varchar, different lengths, not interesting. Here, level is compatible with a lot, because you can already see that from the data sample, this column only contains 0 and 1 as values. So of course, my script says it's compatible with integer, it's compatible with float, it's compatible with numeric, and it's compatible with varchar, because technically that's all true. It can be an integer, 0 and 1 an integer, 0 and 1 is also float, 0 1 is also numeric, 18 2, even if there is no need of 18 numbers to define it and not 2 after the decimal place. Still, technically it fits. And of course, it can very well be a bit, because in my conversion I see that this column contains only 0 and 1, and so it means that it can be converted easily and correctly as a bit. So the output is very, very well defined. But now let's go into the code to show you how this actually works. Okay, let's go quickly to the code itself. Everything is open source and everything is in my GitHub repository. Let's go through the code. Initially, it's very simple. You get variables to define which is your table and which is your schema of the table. Of course, run this in the same database as where the staging table with your data is, or any other table that you want to check the data types on. Then I'm using a temp table to store all the information about the columns and the data types in the current table that we are analyzing. It's trivial. You simply read from the DMVs, the columns, the table, and the data types. Very, very easy. Everything in the same table called calls, because it's all the columns information for me. Then I get a bunch of variables just to make the code work. And then a cursor. You don't see it often, or at least you shouldn't be seeing it often in SQL, but in this case, it makes sense, because I'm going to iterate different code for each row of these calls, because of course I need to run the checks for the first column and then the second, the third. I cannot do it all in the same place. So this is a case when a cursor does actually make sense, even in SQL Server. So we can see that the cursor loops through the rows of my temp table. And what does it do? You can see I have here creating another temp table called results, where you can well imagine that you will store the results inside of results. So no surprises here, trust me. And this is the core of our code. So after fetching the row from our cursor, what do I do? This is the important part. The base SQL is a big piece of dynamic SQL that allows to do this kind of testing. So it will be a little bit difficult to show you as a complete string, because it barely fits. So bear with me. Let's start from the first statement, this one. So it's important to think like the engine and start from where the data is coming from. So as you can see here, we have something that I called X, just because I didn't want to be even longer with this code. But it's basically, remember, this is all dynamic SQL. What am I doing it? It's a subquery where I'm counting, count star, again from, so it's nested, from my table, because you can see I am rewriting my table name here. So it's my schema and my table, where I'm trying to convert the column that I'm currently looking at, this one, column name. I'm trying to convert it, and this is a placeholder because you will see later how are we going to convert it. And then I say, okay, count how many rows you get from the original table that you are testing right now, where converting all of this is not null. So basically it says count the successful conversion of this column in this data type, which is still placeholder, from this column. So you will see in a bit when we are looking about the types to check below here, what does it mean. Then what I'm also doing, I'm also cross-applying another piece of code. Why? You can see it from the name. It's very easy. I'm saying from this same table, please get the maximum length and the minimum length of this table, which then I will store in my results. And then finally, I'm also doing here a cross apply again to get a sample of the data. So you can see again it's nested. Am I doing a string aggregation of a select top 5 from my table? So it's select from the table top 5 and then aggregate the top 5 and then cross apply it into the final table. So at the end, I can get all the information about the column name, data type, if it's compatible or not depends on if I'm able to match the number of rows from the source with the number of rows that I'm trying to convert. As you can see, testing is this one, and this one is coming from where I'm trying to convert, while the baseline is this one, and it's from where I am not trying to convert. It's from the original table. So here I can easily check, is compatible, yes or no, and this only depends if the count of the rows that I try to convert is the same as the original rows. And then you get, of course, the maximum length, the minimum length, and the sample of the data. Now, the use of the placeholder makes absolutely sense, because what am I doing? I'm using this base SQL where I have placeholder as in data type and in try convert, and I'm simply trying, just try, test, and get me the result, each data type. So in the case of integer, I say replace this placeholder with integer, and I simply run it, insert into results, run it. Then I do it with float, with numeric, with varchar, with bit, with date, with datetime, whatever. So here the thing is, one, you can do it however you want, because you simply define the data type that you want to test, and after this ugly piece of dynamic SQL is complete, which is, you can simply say, okay, I want to test a different data type, I want to test something else, I want to test this other thing. For example, for numeric, I just put in 18.2. If you want to test it with something else, you just change the numbers. You just change the way that you want to test it. So again, it's very, very flexible. And if you want to expand on it, it's simply insert another line here to test the data type that you are interested in. So any other fancy data type you can expand to. Then at the end, it's very simple, because after going to the cursor and deallocating it, I just select from the results where the data is actually compatible. And compatible, let me remind you, is if the number of rows counted here in when we are actually trying to convert this one is the same as the count of rows where I'm just selecting from the table. You can see Y and X is the end here, Y and X. So if what I'm testing is the same as my baseline as a count of rows, then I'm done, it's compatible. So at the end, it shouldn't be that much of a complication if you really understood this piece of dynamic SQL here. And most of all, I hope this helps you out when you have something like this to do. Feel free to expand, feel free to give me any kind of feedback, and see you in the next one.